Alright, today we're going to learn how to write linear equations from a table. We learned how to write linear equations from a graph by taking two coordinate points on that line and counting how much they're rising over how much they're running, and then looking to see where the line crossed the y-axis for our y-intercept. We're going to do the same exact thing, except now we're not given a graph, we're given a table of values, and we're going to have to find the slope and the y-intercept. So the equations that we'll be typing into the answer blank will be in slope-intercept form, which again is y equals m times x plus b, where m represents the slope of the line and b represents the y-intercept. So we've got to find the slope and the y-intercept. And there's lots of different ways to do that, so I'm going to show you numerous ways throughout this video. The first thing that I'm going to start with is trying to identify what the slope is. And again, slope is rise over run, which is also the change that's occurring in the y values between 2 points over the change that is occurring between the x values. So if I look at this table, I've got a bunch of different coordinate points on the line from the line if it was graphed. And what I'm trying to do is figure out how much the line is changing in the y over how much it's changing in the x. So if I look at only the y values here and I try to identify how much they're changing, 1 to 2 there's a net change of 1. From 2 to 3 there's a net change of 1. From 3 to 4 there's a net change of 1. And from 4 to 5 there's a net change of 1. So it looks like the y values are changing 1. Well, if I do the same thing for the x, from 0 to 1 there's a net change of 1. From 1 to 2 there's a net change of 1. And from 2 to 3 there's a net change of 1. And from 3 to 4 there's a net change of 1. So it looks like the x values are changing by 1 as well. So now I have the slope, and I haven't really even done any math except for counting. I can simplify this slope, however. 1 divided by 1 is 1. So the slope is 1. We're rising 1 and we're going over 1. Well, there's another way to find slope if the values aren't given to me in sequential order like they were. I'd have to take two coordinate points, so that's what I'm going to do right now, and find the change that's occurring between them. So if I take this coordinate point right here, the coordinate point 4, 5, and the coordinate point, let's take this first one, 0, 1, and I want to find the slope. I'm finding how much the line is changing between them. I'm going to take the y value from one of the coordinate points. So I'm going to take the y value from the bottom one over the x value from the bottom one. So this is the first coordinate point, 4, 5. And if I'm finding the change, then that means I'm subtracting them because I want to know the difference between them. And I'm going to take the y value from the first coordinate point, or the top one, and the x value from that same exact one. And I'm just going to subtract them to find the change. 5 minus 1 is 4, and 4 minus 0 is also 4. 4 divided by 4 can be simplified to 1. So again, it gives us the same exact slope, and it should. So there will be several different ways to find the slope in these examples. Once we find the slope, what we have to do is find the y-intercept. And I know that when the line crosses the y-axis, if we wrote the y-intercept as a coordinate point, the x value for the y-intercept is always going to be 0. So I'm going to go over to this table, and I'm going to look for the x values, and I'm going to try to find the one that has 0 for x, and it looks like this top one has 0 for x. So if x is 0, that means that y value is the y-intercept. So it looks like here our y-intercept is 1. So we've already found the slope. Now we've got the y-intercept. Now let's put it all together. Y equals, our slope is 1 times x, and our y-intercept is a positive 1, so we're going to write plus 1. And then remember, we can simplify this equation because 1 times x is just the same thing as x plus 1. So I'm going to go over here and type it in. Y equals x plus 1. Example number 2. So again, we're going to find the slope first, and then we're going to find the y-intercept. So if we're looking at the table of values, I'm going to find the slope, which is the same thing as change in y over the change in x. So I'm going to count to see how much the y values are changing. Looks like 7 to 8 is a net change of 1. From 8 to 9 is a net change of 1. From 9 to 10 is a net change of 1. And I can do this because the values it gives me are in sequential order, meaning there's some pattern to them. Sometimes you'll be able to do it, sometimes you won't. And this is one of the cases where we can. Now we're going to find the change in x. So from 0 to 2 is a net change of 2. From 2 to 4, there's a net change of 2. And from 4 to 6, there's a net change of 2. So it looks like the change in y is 1, and the change in x is 2. Well, I've found my slope, so now let's find the y-intercept. So we're going to look for where the x is 0, so it looks like this top coordinate point, and that y value for when x is 0 is our y-intercept. So it looks like 7 is our y-intercept. Now we're going to put it all together. So we have y equals our slope, which is 1 over 2, plus our y-intercept is a positive 7, so it's going to be plus 7. And then I'm going to put this into computer form by making sure that I write the x variable in the numerator. So y equals 1 times x over 2 plus 7. And here I don't have to write 1 in front of the x, so I'm going to type in y equals x over 2 plus 7. And I'm done. Example number 3. So hopefully you're starting to feel a little bit more comfortable with finding the slope. I'm not going to count the change that's occurring between the y's and the change that's occurring by the x's. I'm going to do the second way I showed you in the first example, which is take two coordinate points. So I'm going to take this coordinate point right here, 3, 0, and this coordinate point right here. And if I'm finding the slope, I'm finding the change that's occurring between these two coordinates. So I have 0, 6, and I have 3, 0. I'm going to take one of the coordinate points, so I'll just take this bottom coordinate point. And slope is change in y over change in x, so the y value here, 0, will go on top, and the corresponding x value will go right under it. And I'm going to subtract it from the other coordinate point. The y value is 6, and the x value that corresponds to it is 0. So now I have 0 minus 6 is a negative 6, and 3 minus 0 is a positive 3. And if I can simplify this, then I need to. So I have negative 6 divided by 3. Well, a negative divided by a positive is a negative. And 6 divided by 3 is 2. So I found the slope, which is a negative 2. Now I've got to find the y-intercept. So I'm going to look to see if it gives me the x-coordinate where x is 0. And it does, again. So when x is 0, that y value is 6, which means 6 is the y-intercept. And now I'm going to put it all together. So I have y equals, sorry, I'll just type this in. Y equals our slope, which is negative 2 times x. And our y-intercept is 6, so I'm going to write plus 6. Example number 4. I'm going to again find the slope by just taking two coordinate points. So I'm going to look for small ones that are probably pretty easy to subtract. So I'm going to choose this one right here, and I'm going to choose this one right under it. So I have the coordinate point 2, 3, and the coordinate point 3, negative 2. Again, you can count the change that's happening between each y value and the change that's happening between each x, but I'm going to do it this way for now. So I have the coordinate point 3, negative 2, so I'm going to take the y value for that coordinate point, which is negative 2. And right under it, I'm going to put that x value. I'm going to subtract it from the other coordinate point, and the y value here is 3, so 3 goes on top, and the x value is 2, 2 goes on bottom. And I have negative 2 minus 3 as a negative 5, over 3 minus 2 is 1. Negative 5 divided by 1 is just negative 5. So I've found the slope, which is negative 5. Now I've got to find the y-intercept. So I'm going to go up to the table of values and look to see where x is 0. 1, 2, 3. Okay, so right away I know that it's not giving me the y-intercept in the table. None of these coordinate points have 0 for x, so that means we don't know what the y-intercept is by looking at the table. So we're going to have to use math to figure it out. So this is how you figure it out when the table does not give you the y-intercept. we're going to use y equals and mx plus b to find b. We're going to solve for b. So we know what m is now. It's negative 5 times x plus b. And if we're trying to find what b is, what we need to do is replace something with x and y so that we can solve with b. Well, we've got 5 coordinates that we can use to replace x and y with something. So I'm going to choose this first coordinate point, 1, 8, and I'm going to take the x value, plug it in for the x value, the y value, plug it in for the y value. So if I plug in 8 for the y, I'm going to plug in 1 for the x. And you can do this with any of the 5 coordinate points. I've just selected the first one because it looked like it was pretty easy to add and subtract and multiply. And now what we're going to do is just simplify and solve for b. So negative 5 times 1 is just negative 5 plus b equals 8. And if we're solving for b, we need to eliminate this negative 5. I'm going to add 5 to both sides to do so. I have 8 plus 5 is 13. Negative 5 plus 5 is 0. 0 plus b is just b. So now we know that our y-intercept here is 13. So we're going to put it all together. Y equals, our slope is negative 5 times x, and our y-intercept is a positive 13, so we're going to write plus 13. Example number 5. Here we're going to take the bottom 2 coordinate points to find the slope, or the change in y over the change in x, So the coordinate point 2, 5, or 5, 2, and the y value there is 2, the x value is 5. We're going to subtract that from this coordinate point right here. So 4, 1, the y value is 1 and the x value is 4. And now we're just going to do the math. So we have, and if we wanted to label this y2 and y1, we could. This would be y2, this would be our y1, this would be our x1, and this would be our x2. Okay. Now let's do the math. 2 minus 1 is 1. 5 minus 4 is 1. 1 over 1, or 1 divided by 1 is 1. So we know that the slope is a positive 1. Now we got to find the y-intercept. And again, when we look at the table of values, there's no x-coordinate as the value of 0. So we're going to have to do the same exact thing we did in the last example, which is take y equals mx plus b, substitute in our slope, which is 1, times x plus b, and now we're going to plug in values for x and y so that we can substitute or solve for b. So I'm going to choose a value that looks fairly small so that it's easy for me to solve for b. So I'm going to choose 2 and negative 1. Negative 1 is the y value, and 2 is the x value. Sorry, I wrote that wrong. So 1 times the x value is 2 plus b. Now I'm going to simplify and solve. So 1 times 2 is 2. And I can start solving for b. So I'm going to eliminate this 2 by subtracting 2 to both sides. And I have negative 1 minus 3 is, negative 1 minus 2 is negative 3. And this goes to 0, so I'm left with just b. So we know that the y-intercept is a negative 3. And we know that our slope is a positive 1. So I have y equals positive 1 times x. And our y-intercept is negative 3, so we're going to write minus 3 this time. And in fact, I can actually simplify this further. I don't need to write 1 times x, so I'm just going to erase this 1, and I just have x. Y equals x minus 3. Okay, so we got time for one. So here we have a table that only gives us 2 coordinates, and that's fine because we know how to find the slope with 2 coordinates. We're going to take the y value of the bottom coordinate and put that over the x value of that y value, and we're going to subtract that from the other coordinate that it gives us. The y value there is negative 3, and the x value is 5. And when I subtract these, subtract the negative, I'm essentially just adding. So I have 5 plus 3 is 8. 4 minus 5 is a negative 1, and 8 divided by negative 1 is a negative 8. And now I've got to find the y-intercept. Since it doesn't give it to me because I don't see where x is 0, I'm going to take the y value 5 times the slope, which is our m, times x, which is 4, and right plus b. So now I'm going to simplify and solve. So I have negative 8 times 4 is negative 32 equals 5 plus b. I'm going to add 32, add 32. 5 plus 32 is 37. So I have b equals 37. I put these two in, and